Welcome, everyone. Thank you for being with us today. Today, we are going to be learning a little bit more about how to parallelize your Python code with Dask, and then how you can scale to your workflows to using Coiled clusters. If you haven't followed up the instructions here, like you have the tutorial set up to follow, or you can click on the binder button in that GitHub repository, and then you will be able to see there all the material that we're going to be seeing today. So to get started, like, what is Dask? Okay, so Dask provides like multi-core and distributed parallel execution on larger than memory data sets, for example. You can think of the API as kind of like two parts that we do have, like what we call high-level collections, which are Dask DataFrames, Dask Array, Dask Bags, and then what we're going to see more of today is one of the low-level collections, which in our case is going to be Dask Futures. The low-level like collections is it's kind of like the best tool for fine control and build like custom parallel and distributed computations. So you can submit arbitrary functions for computations in parallelized, eager, and non-blocking way. If you are interested in learning more about Dask DataFrames, then you can go to coiled.io/tutorials and sign up for the next tutorial that we're going to be giving in 2 weeks, which is about Dask DataFrames. Here is where you can find like all the recurring tutorials. So we generally give these tutorials every 2 weeks or every 3 weeks. So make sure that you just go there and then check in what do we have in line. So let's get to it. You should have all received, you should all be in this repository. It's the Dask repository. I'm going to make this bigger so folks can see. We are on the first notebook on that repository, Parallelize Your Python Code. And yeah, today we're going to go over and learning more about futures. So as I mentioned before, futures are part of the low-level collections. And then you might wonder, why using futures? Well, it's similar to a work submission style that can emulate a map-reduce paradigm. So if you are familiarized with that, then you will get the hang on how to use Dask futures. Futures, like intermediate results, can be passed to new tasks without having to pull the data locally. So then that makes it like a nice thing to have. And the calls will return immediately. So then there will be no blocking of the Python session. We're going to see in an example like what that actually means. But in the meantime, like, what is a common case where people will use futures? And this is probably a case that you might encounter at work or at school. And that is like when you have, for example, a workflow where you are reading some data, you are from a file, you are transforming that data, and then you're writing that data somewhere else. So, for example, your code might look your serial code might look something like this, where you have a function where you read a file name, and you will like have data that you will transform, and then you have a destination that you write it. And then you probably have like X numbers of files. So then the way that you will process all those files will be by like doing a for loop over the files and then appending the result into a list or some sort of place. Now, what we're going to be learning today is like how you can parallelize that kind of code and with Dask. And then that will be like a fairly easy like task. Like we don't need to change our code much. You will see that our code will be now something like still a for loop, but then we're going to do like a client submit of that function, and then that will like scale it to the rest of the workers that we have. I see that some person asked, could you share the notebook? Thanks, the person who shared the notebook. In that same repository that it's on the chat, you will find a binder button, then if you haven't gone through setup, then you can click on that binder button and then follow along. So today we are going to be working with a specific example where we're going to be scraping data from a Stack Overflow questions page. So let's just get into it. We're going to learn a little bit more about how to kind of navigate the stuff, and then like also see the serial code, and then transition to the parallel code with Dask. So in Stack Overflow, you will see that if you log in now, like just go to Stack Overflow, the questions, you will see that on all the questions, you have a set of posts that are here. And then if you go all the way to the bottom, then you see that there are multiple pages. And each page has about 50 posts per page. So we're going to be playing around with this page initially, and then we're going to see how we're going to get into the post specifically, grab some data, and then do some sort of analysis. So to start, what we want to do is let's just grab the title for multiple pages. And the title of like the Stack Overflow page is like what is usually renders over on top over here in the tab. So to do that, we're going to be doing some web scraping code. I don't want you to hang a lot into what the code is. It's just the idea is this is some function that does a type of work. And in your case, probably you will have a different kind of function in your personal workflow that does something different. The concept will still apply. So for now, we are just going to be using pandas, requests, and then beautiful soap. So we have a function here, which it does gets the questions page title. And then we pass a page number, so from either 1 to n, and then it will give me the title of that page. So if we execute that code, we have like the function, and then let's say that I want to see what's the page title of like the page number 2. So now we'll give page number 2, and then we'll see something over here that says newest questions, page 2, Stack Overflow. And that's like kind of what we expected. Now, if I want to get the page title for the next 8 pages, then what I will do is write a for loop, which goes from 1 to 9, like the page number starts in 1 in this case. And then I will just save that result into a list. So this is like Python code, is like nothing strange here yet. And if we run that, it takes about 2 seconds. And then if I want to check what we have there, we see that we have, for the first 3, nothing too surprising. Question, page number 1, 2, 3, and then if we keep going, that will be. Now, let's do our first exercise where what I want you to do is we're going to import Dask distributed and create our local cluster. So far, we're not going to be yet using like a big cluster. This is a small example. And we're going to create like a client, which is like we connect to our cluster. And here, you will see the beautiful dashboard. And what I want you to try is to parallelize this code. So you can go at the top and check the example that we have here, and then try follow this example and parallelize the code that we just saw running in serial. So the one over here. I will give like 1 or 2 minutes to do that. And in the meantime, there is a question in the chat. There's don't see the link in the repository. Could you repost in the chat? Yes, absolutely. I can share where is the link of the repository. And probably at this time, if you haven't gone through setup, your best chance is to click the binder button in that repository. And then try to kind of like, follow along and catch up. Hopefully, it won't take too long to launch the binder. All right, so by now, like if you give it a try, then let's see what that code will look like. So again, nothing too different from what it was in the introduction at the beginning. So what do we have is like a for loop that goes from 1 to 8, which are the pages that we want to like grab the title from. And then we're submitting this function, which was the function that we just created to grab the title, and then appending the result to our futures list. So let's just run this. And now we should see some action on our dashboard. Like basically, we just get the get questions page title. That was the name of our function. It had 8 tasks and the 8 of them run pretty fast. Each of these ones are one task. So you see that there are like 8 bars over here. And over here on the bottom left, that we have some information about the memory of the workers. So let's check what this looks like. What you can see is the futures. And you can see that here it says finish. I have another question. How did you pull up the task tab? When you created the client over here, then there are 2 ways. Like you can use the button that is up in here that says a launch dashboard in Jupyter Lab, and that will work for the local clusters. And if not, you can click the dashboard link, and then that will send you to the full dashboard on a separate link. Awesome, great question. So let's see what the result looks like. And then we grab all other futures, and then we got dot result. So this is very similar to what we did before. Now, if we want to gather all the results, then we can just like create a list comprehension and then grab all the results for the futures that we just created. So in this case, we'll see from page 1 to 8, and we have all of those in there. Now, if you wanted to time this, in this case, we didn't time it. If you wanted to time this and then compare how long it takes against like the serial case, what you can do is always include the time magic at the top. Now, in this case, because they start like the execution is eager and then it happens. So then we need to actually wait for all of them, all the futures, to be able to actually see how long it takes. So to be able to do that, you can add at the bottom of that cell that we have above, that we have over here, you can actually do wait futures. And then you can add over here the time magic. Now, if you notice, this runs like very, very fast and no action happened on the dashboard. What's happening in here is by default, Dask distributed assumes that all functions are pure, which means that always returns the same output for a given set of inputs. So in this case, Dask is like smart and say, hey, you're not giving me any new inputs. I know this stuff. I'm just like returning it to you. So if we were to actually wanted to run this again and then see how it takes, what you can do is add at the end of the submit call, like a pure equals false. So let's just do that. And pure equals false. So if we now run this and then we wait for the futures, we're going to see how long does this take to run. And it took a second or less than a second compared to the 2 seconds that we were getting before. So that's like quite fast. This is a small example. We'll see like how this gets better as we go. So this is like a very interesting way of like just basically going from a serial code to a parallel one. Everything is embarrassingly parallel. So then every worker is kind of like doing the same task like in parallel. But one thing is, this is a very common kind of workflow. So we do have a simpler interface to perform what we just did above. And that interface is called client map, where what we do is we map that function into the workers. So the code that we wrote above with the for loop and the client submit, it can be written in the exact same way using client map as follows. in this cell. And as we mentioned before, here nothing happens because we didn't add like the pure equals false, and then we already computed or calculated this futures. So if we want to gather the results, we just check, and then we have again our 8 pages. Now, futures are great, and you can basically do multiple things with this, but it's just, this is not, the example that we just saw is not like the only thing that we can do. It says, I have another question. It says, it looks like the time magic doesn't work combined. It should work. I tested it earlier and it should work. Maybe there is like something missing try to add the way futures at the end and then add the pures equals false. Time not found. That's interesting. I apologize for that. I checked it earlier today and then didn't have a problem with the time magic. Maybe, James, if you have any idea why the magic function might not be working, then we can get you some answer over there. All right, so let's keep going. As we said, like futures are great, but now we probably want to do something a little bit more complicated than just grabbing the title. So what we're going to be doing in this case is we're going to grab the page title, the HTML page, get the links of each of these posts for all the pages that we're going. All right, and what we want to do here is just like grab a little bit more of information and then see how actually we can pass futures from one function to another. So here we have this request HTML page. So we're going to be requesting the HTML page. This is very similar to what we were doing before, except that we're not getting the title in this case. We're going to get the page HTML links. So for each page that we are like going through, we're going to grab the links that we have over here. And then we are going to get like all those links, right? So we request a page, we grab the link of that page, and then we get all the post links for that. So that could be a little bit confusing. Let's just see it in action, and then let's see what we're doing. So for the page number 3, for example, we are going to get the link of the page number, and then we're going to provide that feature into the links per page. And then what we can see here is like, oh, I have 50 links for the page 3, which are the 50 links that show on a given page of Stack Overflow. So if we want to see, for example, the first 3 links, those will be this first 3 over here. Now, how do I grab post links for multiple pages? Now I want more than one page, more than the 50 links. Probably if I want to do some sort of like data analysis or something like that, I will want more than that. So the serial code for that would be this over here. We just have a range of, let's say we get the first 4 pages. I give the number of the page to the get page HTML links, and then I will get the post links for each of those pages and then append it to them. So if we run the serial code, should take a few seconds. I'm only getting links. So the length of the page post links is 4 because we have like 4 pages. And then if I want to see how many post links I have per page, we'll just like can gather them with a list comprehension. And then we'll see that each of those have 50. Now, we could do this using client map. So, and we can grab get the first get all those links and then provide that into the next step. So if we do this with client map, it will be the parallel way of running the for loop that we just did before. So first, we're going to get these 4 links. So we do a client map here, and we are going to wait for those. So we wait, and then we just got this 4. We see only 4 tasks, which makes sense because we're only getting for 4 pages. And we just use wait because we just want to get those links first, and we can see them here. They're finished. And then now, this is an exercise. So I want you to use client map and then provide and the page HTML features you got to get the links from those pages. It's like follow your intuition, and kind of replicate more or less this code, but then now instead of having range 1 to 5 or having a for loop, now you will have a list of features that was the one that you just generated. So I'll give you 2 minutes to do that. In the meantime, I'm going to see if there are any questions in the chat. I see the chat is being very active. That's great. Oh, great. So it turns out we found the solution of what was happening with the time magic. Yes, the time magic, it needs to be at the top of the cell. If there is a comment on the top of that, usually it just doesn't work. So great for finding that out. That's a good tip. Always put the time magic at the top. Then, all right. So by now, if you copy pasted and then went through change a couple of things, then your code should look something like this. So what did we do here? We're having client map. Now our new function that we want to map is get post links page, because we're going to want to get the post links per page. But then instead of passing a range, we pass the features that we just waited in the step before. So if we do this now, you're going to see that we get get posting. So we get this 4 new tasks. We can see here immediately it says pending, but they finish right away. So if we check on one of them, it will say finish. And if we want to see, for example, the first 3 links for the page 0, we will do gather that result. So then you see we have 3 links over here. Now, you might have noticed that first we got the links per page, and we waited for that before we got the post links. So what if we didn't need to necessarily wait for all of them, but as soon as they are completed, we could actually start the next function. So fortunately, we do have a function or a way of doing this. So as completed will return features in the order in which they complete, which is it explains more or less what it does. So if we can tell Dask as these features are completed, then kind of keep going. So let's try to modify the exercise that we did before, just using as completed. So we're going to import as completed from Dask distributed. And then here you see we're going to get the client map. We're going to use client map to get the page HTML features. And then we're going to say for p in as completed these features, as these features complete, then get going with the next stuff, which is go and then gather me the links for all the posts in that page. So we're going to run that and then see what happens. And as you see, as they were completed, they kind of kept doing this stuff. This doesn't in this case, necessarily things happens fast. So it's more or less likely that they're going to like finish all of them before we get going. But this is something very useful when you're running like a different kind of computation that they might complete at different times, and then you want to kind of like start the next part. So you can see here that case. So we've been playing around, we've been having some links, but let's do a little bit more complex example, what I like to call a grown-up example. So we're going to scrape, crawl, and get some Stack Overflow data from those posts. So far, what we've done, we gather the page links from the page number. We list all the post links for every page, right? And then we were able to get those 50 links from every page. Now, let's get into each of those links and grab some data. So, for example, when you go to a post, probably I'm going to close this for a second so then we can just see it bigger. So when you go to a post, for example, how to transform Dask data frame to a pandas data frame, you will have a title, like there is like a question body, and then we have like the most answered question, the best answer, and then who was the person that answered that question. So let's try to get all those, and then let's do something with that data. One of the things that we can do is, for example, see which username gets the most best answers when it comes to Dask. Who is the username that gets the most best answers? And then that way we can just check a count and then by username. So then for this, we're just going to get all this data and then aggregate it using some pandas magic. And which of the best usernames is most voted? Like maybe we have some of these best answers are from usernames that are like not necessarily the ones that answer the most. So then maybe there was someone that is the most popular, but it's because just answered one question that was very popular, but hasn't answered other questions related to Dask. So we just want to see those numbers, check who they are. It will be interesting to see who are popular people answering Dask questions and why not. So
yeah, there's a question in the chat.
One thing to notice is and this is likely going to happen when we are like running things in serial and we're putting like so many requests, we are going to hit throttling. And we are putting requests to the Stack Overflow page, and they have a limit. Try not to modify the numbers that we have here in the example. When we go to the parallel part, maybe we can play a little bit more with that. But in the meantime, yeah, if you feel fidgety and then like just control yourself for now until like because you will get like you will hit throttling and then like you won't be able to request for a couple of minutes. So nothing too bad. But Stack Overflow is going to say, hey, you're asking me too many things. Let's just put a pause on that. So let's just try to make some of those plots with this data. So these functions are the first three functions are the ones that we already seen and we've been playing around with. So we got the request HTML page. We got the get page HTML links. So we got like given a page number, I get a link, and then for each of those links at the top of the page, then I get what are the 50 links for the post on that page. So that's up to here. And then the new thing that we're going to be playing with now is grabbing some data from those 50 links. So this code, it's a little bit messy and junky, and probably you might have some junky Python code that you want to parallelize and then do things. I am not an expert on scraping. This was an attempt to get some data. If you know how to make this prettier, you're more than welcome to make a pull request. For now, I don't want you to spend too much time knowing what this code does. Just the important thing is we are grabbing the title, the question, we're getting like the best answer votes, if there is an answer, and we're grabbing like who answered that best answer and getting that link. So this will like give us a dictionary well like with those with that information. So get that. Now, the first thing that someone will do is an attempt to do this is run it in serial. It's It's usually easier to visualize things in serial before like going to the parallel code. So let's try to do this. There is a high chance that when we're trying to do this, we're going to hit throttling, but maybe not. It depends. So before we run it, let's just take a look a little bit at this code. So what we say is for page number in, what we've been doing before is like, I'm doing only 2 pages because I know that that's the number that more or less sometimes runs, but sometimes doesn't. We're going to get the links of given a page number. We're going to give those links to the get post links per page. So far, nothing too new. We're going to create a new, we're creating like a new list. And then for each of those links that we get, of the 50 links per page, we are going to get the data and append that data into that list. And then once it's done, then I'm creating here like a data frame with all that information. And at the end, I will get like a list of data frames. Before hitting this, I see that there was a question and it says, what was the significance of including as completed in the last for loop? Won't you need to wait for that loop to complete before you can do anything useful with post links futures? That's a good question. If I understand the question, which I think it did, is like, what is the point of adding as completed in here? And it says like, you will need, that being said, like you will need to wait until that for loop is done to be able to do anything with post links futures. Yes, that's true. Like if I want to do something with post links futures, then I need to wait for this. The difference and the reason why you might consider using as completed is because of performance. You would like this to complete as fast as possible. So as the first set of futures is completed, then I want to be ready to give more work to my workers. I want to be ready and not let my workers sit in there. In the previous case, we waited for all this page HTML futures to be done until we started the next part, until we computed the next futures. In that case, like there is a period of time that my workers might not be doing anything. By using as completed, I'm telling my worker like, as you finish this task, get going with the next one. So that's the advantage. In this case, like we have something that runs quite fast, so it's like not necessarily it's not optimizing it a lot, but it's like telling like the worker, hey, as you finish this task, I want to send that worker like a new task to keep it busy. So overall, then this will like take shorter amount of time. Great question. So going back to the serial code over here, let's try to run this and then get the data. So I'm going to run it, and usually this takes about 30 seconds. When it runs, there is likely chances that I will hit throttling. If that happens, we will see probably like a red message that says that it's not finding the data or it's not finding the there we go. Okay, so here's what happens. It says attribute non-type object has no attribute text. And this error message is not very informative. I personally know that what happened here is we hit throttling because of 2 reasons. So in one case, you can see that df list, there is some information in there. So it starts grabbing the pages and stuff. But if I check the length of it, this is 1, so there's only 1 page. And as it was going through the second one, it seems like Stack Overflow didn't like that. And the way I know that we hit throttling is because if I try to reload this, now it keeps hanging in there. It keeps hanging in there, and it just doesn't load. And this tells me that for a little bit, I'm kind of like more or less banned to make requests to Stack Overflow or to see things. So that's kind of like a bummer. Like if I'm trying to do this analysis, I wouldn't like to hit on this. But yeah, if you see over here, it says too many requests, and then it's telling me that, hey, you've been requesting too many things. You will probably temporarily ban, more or less. So how do we avoid that? Can we avoid this and still get some data? And the answer is yes, we can. Initially, for one page, this will look like such a data frame. So then let's just try to get a data frame for all the other pages. So how do we avoid the throttling? Well, I'm going to currently close the cluster that I have open locally, and then we're going to go to a Coiled cluster. And here is the thing. Going to a cluster, the cluster will have multiple VMs, each worker is if it has its own IP address. So to Stack Overflow, the request that comes from each of those workers is going to be as if it came from a completely different machine. And that's one great way of going around this problem. So let's get you all on trying Coiled. If you are a Windows user and you are running this on Windows, you will need to run the following command, not on the notebook, but on the command Anaconda command prompt on PowerShell. If you're running things locally, if you're using Binder, you should be fine. Now, how do we log into Coiled? So I'm already logged in, but for those of you that you haven't logged in, you should have followed the instructions to be accepted into the Dask tutorial Coiled team. So you should see something like this. I also see some people getting some clusters going. Nice. So if you should have accepted an invitation to this team, and you should have your account. So what I need you to do is create a token, and then you will go over here and do create an API token. I'm going to make this bigger in case folks do not see that. I'm going to create one, and immediately after, revoke it. I already have one. I'm already logged in. But if you haven't, then create an API token. You can put it like Dask tutorial test. I'm putting a test, but you can name it anyway. You can do create. And then in here, it will give you a token. I want you to copy this token over here. And I'm going to revoke this now. But I want you to copy that token in here and then paste it right in there. And then uncomment this line. Remember to keep this account Dask tutorial. So then that means that you're going to be using our team account. Otherwise, if you don't do that and you haven't gone through setting up your own cloud account, this kind of will throw you some problems. So if you accept it to be on the team, then you go ahead and then do this. Use your own token. I am going to, for now, remove this here, just leave it as a comment. And then after you run that, then you import Coiled. And here we are just creating a cluster ID. It's just to have everyone have a different name for their clusters. Otherwise, we're going to be reusing each other's clusters, and this is going to cause a problem. So this is a way of having a random number that we are going to use on the name of the cluster. And this is how you create a Coiled cluster. So we are going to launch a cluster. Coiled is smart enough to sync up the packages that you have installed on your environment. If you follow the setup if you are running things locally and you follow the setup, then on that conda environment that you create, Coiled will grab those and then put them on the cluster for you, and then you don't have to worry about package management and then syncing those things. If you're on Binder, then it will do the same from the Binder session. So we're going to just get and workers equal 10. Make sure that you create, you just don't remove this. So we're going to try to get a cluster. So here we have a widget that is kind of telling us what is happening. So you can see this over here, and then we can see on the dashboard at the same time. So I'm going to share this so folks can see things in there. So I see here, it says kind of like, I will guess the minus this one because it says 11D3. It says created also by me, and I see other folks are creating clusters there too. It says scaling, and then it has some information over there. And if I want to know a little bit more what's happening, then I can look into the widget over here, which it tells me like it's requesting the things. So it was provisioning, now it's downloading the environment. And this is like a very nice info. So I know what's happening while I'm waiting. And then I know it's kind of working. So then now it says it's downloading the environment. This will take around 1 minute, 1 minute and a half, not too long. And as soon as we get like around 60% of the workers ready, then Coiled will allow me just to kind of like get going and do my computations. So for now, we're seeing still on the downloading environment part. Do we have any questions so far while we wait for our clusters? One common question that tends to happen is it's like kind of learning a little bit more what's happening here. So then you can see that we get package sync. That was like the software environment taking care of that. I see that some clusters getting 9 out of 10, and they started like around a little bit before me. So then probably soon I'm going to get my workers. And we have some information over here about here you will stop the cluster. And then when the dashboard is available, we're going to see it over here. So far it's not available. I haven't gotten my my workers yet. For some reason, it's taking a little bit longer than usual. But we're going to get them. We're going to get them, confident we're going to get our, everyone else is getting them, so I should get them. But yeah, for those of you that you already have your cluster and you are ready, here is how we will connect. There we go. Now we're getting the things. You can see the progress over here in the cloud dashboard, as well as you can see it here on the widget. So since we are getting our clusters and we're almost ready, so I am going to go back to the notebook so we can see things bigger. And now we're going to connect to that cluster. So that cluster is in the cloud. My notebook, in my case, is in my laptop. In some of other cases, might be in Binder. So we just need to connect here. The button in this case won't necessarily work. There's like a small stuff that we're fixing. Feel free to click this link. The link, it will send you to the dashboard. So what I usually like to do is I keep on one side the dashboard, and then on the other side, I'm trying to make this smaller. On the other side, I like to keep the notebook. So I connect it there. You can see here, like there's like a nice display, like a render HTML that tells me I have 10 workers, 40 threads. I have all this memory, and there is information about the schedulers and even down the workers, and you can explore each worker, how much memory I have and how many threads, if you want to get more into that. But let's just try to run the thing, and let's try to get like this data that we've been wanting to. So here is like the parallel code of that for loop, double for loop that we have in serial that we're like trying to get this data. So first, we're going to wait for, we're going to get the page HTML links. And then in this case, we are going to wait for those. And once we have those, which usually happen really fast, then we're going to get the links for each of those pages, like the 50 links per page. And then as those are completed, as I'm getting those, which we call it like crawling, the reason I call it crawling links because now I'm going to get in those links. I'm going to crawl into those links, and then I'm going to get the data from there. So for every feature in crawling, what I need is like the list of links. In this case, I need to do the dot result because I need the actual list, not just the feature. And then I will grab for every link on that list of links, I want to get the data. So I'm going to do a client submit get data, and then I'm going to just grab the data from each of those links and then append that data into here. And we're just going to wait for them so then we can do something. So let's see how long this takes. Shouldn't be too long. We should see some action here on the dashboard. I'm going to refresh so then folks can see it better. But then you see that like, oh, cool, bunch of things are happening. And there is like around 500 tasks, which makes sense. Like if we did 10 pages and we have 50 links per page, 500 tasks made sense. And then we see all the get data happening. And this one's happened, the get page link here. We kind of waited for them. And then we got the postings. So that took 10 seconds. That was like pretty fast. Like in the past, like when I've been able to do one page on the serial code, it took like about 15 seconds. So then that's a lot to wait. And if we wanted to do way more pages, we could probably just get even more workers and then do even more stuff on about the same time. So we check the length here. This will be 10. And then we see all the features finish. And there are so many. So let's get this into something that we can work with, and then we can make some plots. So one way is like if you check here, the type of this is a dictionary. And this makes sense because we collect things as a dictionary. So we can convert that into a data frame because we know that dictionaries map to data frames. So we're going to do client.map pandas data frames into my dictionary. So then like I can get that going. So when I do that, oops, something happens here in the dashboard and it froze. Okay, that happened very fast. You see like in the right part. So if I take a look at the features, then it says it's finished. So here is an exercise that it says, write a function that returns the value counts of the best answer username and apply it to the data frame futures. So now we have like data frame futures, and I want you to create a function that does that. We could actually, for sorry about the size, I could give you the function. Let's try to, like as an exercise, map that into the features that we have. So the function is basically we are returning the data frame column best answer username, and we're doing the value count on that. I want you to map that function into the features we have and give you like 1 minute or so. I see there is a question, so here it is. When you have multiple assignments like map and submit in the code, how are workers assigned this task? Can one worker still at the map while others are down at the submit? That's a good question. I think in this case, the one that we had above, so for example, for the first map, we're putting a wait here. So in that case, nothing is happening until all of this are done. For the second one, this is the beauty of as completed. Basically, as each of these workers are completed, like they complete the task assigned by the map, then they can keep going. So the answer is it depends. If you are waiting for the map to happen at all time, if you're doing as completed, then as they are completed, then they're gonna continue with the task down here, the submit. Nice question. Okay, so to kind of like go over that exercise, we see here that we have that function, and then this is nothing like different than what we've done before. What we are doing here is like mapping the function that we get here into the data frame futures. So if I just run this, then I will see that I have a series over here, and I get like the Throttling has best answer. The value counts as 19 best answers, which it is sort of to expect, given the fact that Throttling was the creator of Dask, and then at the beginning was probably the only one answering all these questions, or he's actually one of the ones that knows the most about this. So that will get the things. So another exercise will be now, if I'll just give you the function, then let's try to map this group by into the data frame futures. So now we're going to see something slightly different. So it's nothing too different to what we saw before. It's like I can let you do this like home for the sake of time. We're going to kind of go over this, but you can just get the most votes by doing this. So then we can see here, and now if we see most votes futures, and then let's say just 0.result, then we'll get like who got the most votes. And in this case, like they're not necessarily ordered, but you can see that Throttling got 45, and then Martin Duran got 10. So that's like a nice thing. In this case, we're just going to aggregate those results and then just get to see the plot. Again, there's like nothing too different from what we've done before. Now we're like in Pandas world. So we're just going to gather all the results from what we saw here instead of just like checking into only one. And now we're just going to move into Pandas world. Like if I show you now what most votes res is, we'll have like multiple series, one after the other one. So we probably want to kind of like get them all together and then do that. So just going to comment this here. And basically, we're going to concatenate all this and then sort them. This is purely Pandas code, so nothing too crazy over here. And then we're just going to plot this stuff. So what we've done here is now we end up with a bunch of like Pandas data frames or Pandas series, and then now we are in Pandas world. So like we are not longer doing things with Dask. We reduce things to something that we know how to work with, and then time to plot. So here are the two plots that are kind of like interesting plots. So who gets most best answers? So it seems like the amount of votes for most best answers is 175. So Matt Throttling, then Martin Duran. And then there seems like there's no answer, which is like, we didn't have an answer to some of those questions. And then Sultan over here, like someone that is very active on the Stack Overflow community. Now, if I want to see who get the most votes, is necessarily one of these, or like was someone that got a lot of votes out of like maybe one question. And I see that there is like a lot of votes for Matt Throttling and Martin Duran, but then there is another user showing up over here that it's a different user than the ones that got most answer up in here. So that's an interesting result. One thing to say, and this is like a segue and an invitation for our next tutorial, is in general, like once we have Pandas data frames, we would like to probably work with something that is more data frame-like instead of like mapping all these functions. So Dask data frame is what we will need here. So you can do all these operations still with futures, but one way is once we have all these Pandas data frame futures, then let's just get it into one big kind of data frame that is partitioned, and then we can work with that on simple data frame syntax. So the way that you could do that is using from delay, and that will get, what we'll get now is something that is like a data frame. So we're more familiarized with this. At the moment, this is lazy evaluated. It hasn't computed the components of the data frame. And you can see this here that says M partitions. So those are each of the data frames that we have in Futures now is a partition of our Dask data frames. And then we have all the things like on the top. And then you can do operations like in data framework. So it's like columns, and then you could actually do the group bys and the value counts the same way that we did it before. So I'm just going to show you how those aggregations look and how the group by looks. This is like all what I have for you today. I see there are some questions. We're going to get to it. If you're interested in learning more about Dask data frames, go to there's an extra exercise at the bottom here to do at home. But you can go to the coiled.io /tutorials, and then you can register for the next tutorial on data frames. And then we're going to be seeing cool things with like a big data frame on the New York City Uber Lyft data set. So I see we have like 2 questions, so then, or 3. Let me see, 2. So one was a follow-up to the what happens when we have, so we have an initial question that was, when you have 2 multiple assignments like map and submit in the code, how are workers assigned this task? Can one worker still map while others are down at the submit function? And we saw that depends on whether you're waiting or you're like using as completed. And then the follow-up question was, so the workers all share the same code and can be invoked when client submit is called? I'm not entirely sure what do we mean by share the same code, but workers are assigned tasks. And those tasks have like the instructions to do the thing that they need to do. So maybe it would be more or less that I don't entirely know if the exact wording will be shared code, but they do have the information that they need to get going. Like here you saw that as things move, we have tasks assigned. So they will have those tasks in the queue. Maybe James might be able to comment on this. Yeah, so the question was, like the first question was, when you have 2 multiple assignments like map and submit in the code, how are workers assigned this task? Can one worker still map while others are down at the submit function? And we said like in that case, it depends because if you're waiting or not, if you're using as completed or not. And then the follow-up question was, so the workers all share the same code and can be invoked when client submit is called? Please correct me if I'm wrong. The main thread, so to speak, is owned by the master node, and this master node delegates distributed work, calling map and submit. I'm not sure if that's the case. Jamie, if you can comment on that, that will be great.
Yes, workers, the first question about map and submit, I mean, workers are totally capable of running multiple, like when users type in map or submit, they can totally run those at the same time, assuming the graph structure is such that like, you know, we don't have dependent nodes, like graph structure leading to, no, you have to run task A before you can run task B because task B depends on task A. So hopefully that answers that question. Basically, whenever you do a client.map or client.submit, Dask will submit tasks to the scheduler will coordinate and then submit those to the workers. And then for the second question about, I think, correct me if I'm wrong here, whoever asked it, but I think you're asking about like, does the same software environment need to be on the client and workers and scheduler? The answer to that is yes. Code basically gets serialized back and forth between different nodes in the cluster. So you do need to have the same. So for example, if you're doing a client.submit function and that function uses, for example, NumPy.
Let me know when.
You will need to, I'll just tell Maddie we'll do. That function, for example, uses NumPy. You'll need to have NumPy installed on the workers as well. Basically, it just pickles the function you define that in this case example uses NumPy, and it'll then expect NumPy to be on the other end whenever the function actually gets run. So you do need to have the same software environment throughout the cluster. Hopefully that answers the question. Let me know if it doesn't.
Actually, there's just another question. Is that data frame is parallelizable? Yes, absolutely. Actually, if I'm still sharing my screen, you might have seen towards the end, let me just like compute something else, but that's data frame. If I recompute, you will see this is happening like very fast, but there are all these tasks like happening over here. So if you want to learn more about Dask data frames, join us like in 2 weeks. You can register in coiled.io/tutorials, where we are going to actually be working with more exciting data frames and then big data. Thank you all. I hope you have a nice day. Goodbye.